Okay, this lesson is called Projectile Motion Word Problems. And it's going to be a little tricky because some of the examples are long. So I have 4 examples today, but examples 3 and 4 each have like 6 parts to them. So those are going to be a little tricky. We'll start with the quick one though. Well, before we do that, a common type of application of quadratic functions are called projectile motion word problems. Okay. So for our purposes, a projectile is any object that is thrown, shot, or dropped. Okay, so example 1. An object is 4,900 feet above the ground. The object falls, and its height is given by this quadratic function. H of t equals negative 16t squared plus 4,900. The height of the object above the ground is in feet, and the time t is in seconds. Determine when the object hits the ground. Okay, so let me just recopy down this equation right here. We're going to use h of t equals negative 16t squared plus 4,900. Now it says above that t is the time in seconds. And h of t, this is your height. Okay, so the question is, when will the object hit the ground? So think to yourself, what is the height when the object hits the ground? What is the height when the object hits the ground? The height is 0. So I'm going to replace h of t with 0 because the height is 0 when the object hits the ground. Okay? Now there's a couple ways you could think about this. Okay, a couple ways to go about this problem right here. Okay? We have to solve it for t. Solve it for t. So there's a bunch of ways you could do this. I am going to solve it using square roots. So, I mean, I guess you could use the quadratic formula if you want. But I'm going to solve it using square roots. I'm going to get t squared by itself. So I will add, well, this should be negative. My bad. That should be negative. I forgot to copy that negative sign. Okay. I am going to get t by itself. So in order to get t by itself, I will add 16t squared to each side. So I will have 16t squared equals 4,900. Then I will divide each side by 16. When I divide each side by 16, I get t squared equals 4,900 divided by 16 is 306.25. If I want to solve for t and I have t squared, think back to the last unit. You are going to take the square root of each side. So the square root of t squared is just t. And you're going to take positive and negative square root of 306.25. Okay, so now use a calculator and get the square root of 306.25. And you're going to get t equals positive and negative. The square root of 306.25 is 17.5. Okay. Now let's think about this logically because this is a word problem. Okay. So this is saying t equals positive 17.5 and t equals negative 17.5. You cannot have a negative time. Okay. So the answer will be just the positive number. The object hits the ground in 17.5 seconds. Okay? The object hits the ground in 17.5 seconds. Okay? That one wasn't too bad, I don't think. The ones we do later are going to be much longer, so those will be more difficult. Okay. Let's move on. Let's move on to example 2. A bird is flying in the air. The bird's path can be modeled by the quadratic equation y equals negative x squared plus 13x minus 30, where y is the height in yards and x is the distance traveled in yards. What is the bird's maximum height and what is the total distance it travels? Okay, so when I see maximum height, the first thing I think of is find the vertex. So we are going to find the vertex. We'll find the vertex to get the maximum height first, and then we'll focus on the distance it travels, okay? So let's find the vertex. Let's start with the axis of symmetry. X equals opposite of b is divided by 2 times a. So x equals negative 13 divided by 2 times a, which is 2 times negative 1, okay? So negative 13, opposite of b, divided by 2 times negative 1. That gives you negative 13 divided by negative 2. That gives you x equals 6.5. That is the x value of the vertex. Now let's find the y value of the vertex. Okay, y equals negative x squared plus 13x minus 30. Replace the x with 6.5. And this is going to be a little tricky. That should be minus 30. Let me fix that really quick. Okay, there we go. Now we have a little bit of an order of operations situation going on here, okay? You have to do 6.5 squared times negative 1, okay? It's not negative 6.5 times negative 6.5. It's 6.5 times 6.5 and then times negative 1, okay? So 6.5 times 6.5 times negative 1 gives you y equals negative 42.25. 13 times 6.5 will be plus 84.5. And then minus 30. So now combine those and you get, let's see, 84.5 minus 30 minus 42.25. You should get y equals 12.25. So that's my answer for part 1. I'll write it in a sentence at the end because these are word problems. You want to put your answers in sentences. So that'll be my answer at the end. I'm just going to jot down now. That is the maximum height. I will come back to that at the end of the problem when I write out my answer. Okay, so what is the bird's maximum height? We got that. What is the total distance it travels? Okay. Let me recopy the equation from above. So so the bird is starting on the ground, then it's going to fly, and then it's going to land on the ground. So what is the difference it travels from when it starts on the ground to when it flies and when it lands on the ground? So the height when it's on the ground is 0. Okay. Now I'm going to factor, okay? When you factor and it's 1x squared, it is easy to factor. So what I'm going to do is I'm going to factor out a negative 1. And when I do that, it leaves me with this. X squared minus 13x plus 30. And now I'm going to factor this trinomial in parentheses. What multiplies to 30 and adds to negative 13? That is the question. What multiplies to 30 and adds to negative 13? Think about that for a second. But it's negative 3 and negative 10. So now you are multiplying three things to get 0. Set each one equal to 0 and solve. You can ignore the negative 1. Negative 1 cannot equal 0. You can ignore that. But you're going to do x minus 3 equals 0. Solve that. And x minus 10 equals 0 and solve that. So you get x equals 3 and x equals 10. So let's think about this. Here's what we have going on, okay? The bird is flying. The bird is starting on the ground, it's flying, and then it's landing back on the ground. It's starting at 3. And it's landing at 10. And we already established the maximum height way up here is 12.25. So in a sense, the bird is flying from 3 to 10. So how far is it flying? It's flying 7 yards. And by the way, the axis of symmetry is 6.5. It's halfway in between those 2 points. But anyway, the bird is starting at 3. It's flying. It's landing at 10. So it flew 7 yards because 10 minus 3 is 7. Okay. So I'll say this is the distance traveled. So let's put our final 2 answers in sentences. You always want to write your final answer in sentences for word problems. The bird's maximum height above is 12.25 yards. The bird's maximum height is 12.25 yards, and the total distance traveled is 7 yards. Those are the 2 questions. All right. Let's move on to example 3, which is a little long, but okay, it's okay. This one has 5 parts. If you are in school and not distance learning, when I gave you the packet, I left a blank page in the next behind this because it's going to be a little long. Okay, so that's why I left you a blank page. A missile is fired straight into the air. The missile's height in feet is given by this formula, where t is the time in seconds after it is fired. Okay, so part A, how high is the missile after 4.5 seconds? This one's pretty straightforward. T is the time in seconds. Let me just recopy the formula above. This is the formula we're given above. T is the time in seconds. So how high is the missile in the air after 5.5 seconds? Replace the T with 4.5. So we are evaluating h of 4.5. So negative 16 times 4.5 squared plus 400 times 4.5 plus 100. Okay, this is part A. Order of operations, 4.5 squared, do 4.5 squared, and then multiply by negative 16. okay? Everybody, if you're at home, you should, and you're watching the video, you should do that and make sure you got the right answer, okay? But when you do that, 4.5 squared first, then times negative 16 should give you negative 324, and then plus 400 times 4.5 will be plus 1800, and then plus 100. So when you add those up, you should get 1,576. Since it's a word problem, you're going to write a sentence answer for each. I know it's a lot, but since it's 5 parts, but I'm going to say the missile is 1,576 feet. In the air after 4.5 seconds. Part B. At what time will the missile reach its maximum height? That is basically like you're finding the axis of symmetry, okay? Because the T is your X. So for part B, just to give you a heads up of what I'm doing, find the axis of symmetry. So in the past, we've said X equals opposite of B over 2A. I'll use T this time because we have T. Okay, so T equals opposite of B, negative 400, divided by 2 times A, 2 times negative 16. That means you have negative 400 divided by negative 32. And when you divide that, you get T equals 12.5. And then put it in a sentence. The missile will reach its maximum height after 12.5 seconds. .5 seconds. Okay, so let's put your final answers in sentences. Okay, part C, what is the maximum height? So that is, if you think back to lesson 2, that is the y value of the vertex. So we are going to find the vertex for part C. I'm going to do that in the back. So I'll say part C, find the vertex. So I'm going to recopy the equation from the original problem. H of t equals negative 16t squared plus 400t plus 100. And if you think back, whenever you want to find the vertex, you take your axis of symmetry from part B and you substitute that in for x, or in this case t. So I'm taking my answer from the last question, which is part B. It was 12.5, and I am replacing t with 12.5. And now be careful for the order of operation. So if you're doing this, if you're watching this video, try it on your own first. So maybe pause the video, but you're doing 12.5 squared times negative 16. That should give you negative 2,500, okay? Plus 400 times 12.5 will be plus 5,000 plus 100. That'll give you 2,600, okay? That's the y value. You don't have to write the vertex as an ordered pair. You just have to say the maximum height of the missile is 2,600 feet. Part D. What is part D? When will the missile be 2,500 feet above the ground? Oh boy, okay. When will the missile be 2,500 feet above the ground? Let me recopy the original problem again. Here's the original problem. When will the missile be 2,500 feet above the ground? You're going to replace the height, h of t, with 2,500 and solve. You can solve this using any of the methods from Unit 2, or Unit 3 actually, solving Unit 3. You can try factoring maybe, you can try square roots, you can try completing the square, or you can try quadratic formula. Now I am going to get this equal to 0, so I'm going to subtract 2,500 on each side, and it's going to give me the following. Subtract 2,500 on each side, and this is what you get. Now, I am going to factor the right side of the equation. This has a GCF of negative 16, so I am going to factor out the negative 16, and it leaves me with the following. I did say earlier in the year that we need to know how to factor because we're going to use it a lot throughout the year, and I was not lying. Okay, we are using factoring right now. I factored out a negative 16, and this is what I'm left with. Okay. So at this point, now you are going to factor this trinomial in parentheses. Okay. Find two numbers that multiply to 150 and add to negative 25. It's negative 15 and negative 10. So if you solve each of these, t minus 15 equals 0 gives you t equals 15. T minus 10 equals 0 gives you t equals 10. So my final answer in a sentence, the missile will be 2,500 feet above the ground at 10 seconds and 15 seconds. 10 seconds and 15 seconds. Okay. Just think about it. These are parabolas, so it's going up and then it's coming back down. That's why it's 1,500. That's why it's 2,500 feet above the ground two separate times. Okay. And then part E, same thing as part D, except that when will the missile be 100 feet above the ground? So let me recopy the formula from the beginning problem like I've been doing. This time, when will it be 100 feet above the ground? Subtract 100 on each side, so you get 0, interesting, equals negative 16t squared plus 400t. Now I'm going to factor the right. I am going to take out the common factor of negative 16t. And when I do that, I get t minus 25. Right? Think back to Unit 3, factoring out a GCF. And now I'm going to solve each of these. I have t equals 0, and I have t minus 25 equals 0, which means t equals 25. So the missile is 100 feet above the ground at 0 seconds and 25 seconds. Put that in a sentence. The missile will be 100 feet above the ground at 0 seconds and 25 seconds. Okay. All right. If you made it this far in the video, good. You got one more problem. One more problem. Might want to take a break because the next problem is also going to be long. So one more to go. All right, here we go. Last example. The height and feet of a basketball that is thrown can be modeled by the formula f of x equals negative 16x squared plus 32x, where x is the time in seconds after it is thrown. Part A, how long does it take the basketball to reach its maximum height? That is the axis of symmetry. So part A, I'm going to write down, find the axis of symmetry. So x equals opposite of b over 2a. So opposite of b will be negative 32. Divided by 2 times a, and a is negative 16. So negative 32 divided by negative 32, x equals 1. So put your answer in the sentence. The basketball will reach its maximum height in 1 second. Not a very powerful throw. It's not exactly an NBA caliber point guard right here. Will reach its maximum height. This is no Jared Bynum for all you PC fans out there, okay? Shout out to you if you know who that is. Okay. Okay, part B. What is the basketball's maximum height? That is the vertex. You're going to find the y value of the vertex. So I'll say find the vertex. Let me start by recopying down the entire formula from the problem above. It was f of x equals negative 16x squared plus 32x. And you're going to substitute 1 for x. So f of 1 equals negative 16 times 1 squared plus 32 times 1. Just be careful, this is not negative 16 squared, it's 1 squared and then times negative 16. So negative 16 plus 32. So the maximum height is 16 feet. Interesting. The basketball's maximum height is 16 feet. Always be careful for writing your sentences using the proper units. Okay. Part C. What is the basketball's height? A quarter of the way through its flight. Okay? So you got to think about this logically. Let me go on the next page and let me just recopy the formula first. Okay? Okay. So think about it. Okay. Part A, it takes 1 second to go halfway. So you want half of that. For 1/4, it's half of a half. So it's halfway to 1 second. So this is 0.5 seconds you want. So in a sense, you're replacing x with 0.5, okay? So for part C, you are going to replace the x with 0.5. Tricky, tricky. But if 1 second is halfway, then 1/4 of the way is 0.5. Half of halfway. Order operations it up, 0.5 squared. 0.5 squared is, let's see, 0.25. 0.25 times -16 is -4 plus 16. That gives you 12. So the basketball's height, again, a sentence. The basketball's height, 1/4 of the way through its flight is 12 feet. Part D. Okay. So what was part D again? Okay. Part D, if you look back at the previous page, what is the basketball's height halfway through its flight? So if we're starting on the ground, which we are, okay, we're starting on the ground, there's no C value, so you're starting at the ground. You don't have to do any work for this, because the basketball's height halfway through its flight is the vertex. So we got that. So we don't have to do any work. So for part D, I'm just going to say use the vertex. The basketball's height halfway through its flight is the same answer as we got in part B, which was 16 feet. Two more parts, and then we are done. Okay. Part E. What is the height 3/4 of the way through its flight? So think about it. Okay, think about it. If you're starting on the ground, which we are doing, okay, if we're starting on the ground, then shouldn't 1/4 of the way and 3/4 of the way be the same answer? Okay, so shouldn't this answer be the same as part C? Yes, it should, but let's do it out anyway, okay? So if 1 second is halfway, 0.5 seconds is 1/4 of the way, I am going to use 1.5 seconds for part E, okay? So let me, again, I'm just going to recopy the formula for this problem. And this time I'm using 1.5 seconds for X. And I told you before, I'm expecting it to be the same answer as part C. So let's see if it is, okay? He says, like he doesn't know the answer already, okay? 1.5 squared times -16. Again, do it on your own to make sure you're doing it right. 1.5 squared first, 10 times negative 16 gives you negative 36 plus 48. So it is, in fact, 12. The same answer as part C, which I mentioned earlier. So put it in a sentence. The basketball's height three-quarters of the way through its flight is 12 feet. Okay, last one. Woo! How long is the basketball in the air? Okay, so if you're starting at the ground, which this one is, because there's no C value, then if it takes 1 second to reach the maximum height, and it should take 1 more second to land at the ground. So I anticipate this answer being 2 seconds, okay, because I can just double that and get 2 seconds. But that's only because you're starting at the ground because there's no C value, okay? If you were not starting at the ground, then you cannot do that. But I anticipate the answer being 0 seconds, being 2 seconds. Well, let's see if that's true. There you go. Let me start by recopying the formula. F of x equals negative 16x squared plus 32 times x. And again, the question, how long is it in the air? Well, the height should be 0 when it hits the ground. I'm trying to figure out when it hits the ground. So I replace f of x with 0. I'm going to solve that for x. I'm going to factor out the GCF of negative 16x, and it leaves me with x minus 2. That's from unit 3. Solve it. X equals 0. X minus 2 equals 0, which gives you x equals 2. So again, this is saying the basketball is on the ground at 0 seconds, then it's thrown, and then it lands back on the ground at 2 seconds. So the basketball is in the air for 2 seconds. Okay. And that is the end to that very long lesson of projectile motion word problems. Time to go celebrate, and that we're done with this long, long lesson.